Hey guys, Dr. K again. So today again I'm going to do a motion related problem involving Newton's laws. It involves friction, applied force, normal force, the gravitational force. So it's going to be an exciting force. I'm hoping that you will learn some important techniques um, when solving this type of a problem. Okay, so let's go ahead and check out this problem now. Okay, this is the problem. So I have an object, 10 kilogram mass, and it's sliding on a rough surface. Okay, how do I know it's rough? Look, coefficient of kinetic friction is given as zero point 0.4. 10 kilogram mass sliding because there's a force applied. Someone is like maybe like pulling in this direction, so there's a force applied 56 newtons at an angle of 30 degrees with the horizontal. Because of that force, the object is sliding to the right. Okay, if the object is sliding to the right, find the kinetic friction force between the mass and the flow. Okay, so that's the first thing. We need to find the kinetic friction force. And then its acceleration. I told you it's sliding to the right, so we need to find the acceleration. What do you do in a problem like this? When you try to solve a problem like this, the very first thing that you need to do is draw the free body diagram. Okay, FBD. So I'm going to draw that FBD, the free body diagram. Okay, so I'm going to replace the object by a dot and then draw all the forces. I always start with the gravitational force. You can't go wrong with the gravitational force, right? It's vertically downward. So I'm going to write that as F sub G. Okay? And then there's a contact between the object and the surface. As a result, there's an upward force acting on the object due to the surface, and that is what we call the normal force. So this is the normal force acting on the object, F of n. Okay, and then there's an applied force. That's the applied force. So even though a number is given as 56 newtons, I'm just going to denote that as F applied. Okay, F applied. And that's going to make an angle with the horizontal 30 degrees. Now, because of this applied force, the object tends to move to the right. It's moving to the right. It tends to move in that right hand side direction. As a result, there's going to be a friction force in the opposite direction, and that's a kinetic friction force because it's in motion, right? So then I need to draw the kinetic friction force F of k, F sub k. That's the free body diagram related to this problem. Okay, so now I'm going to put the numbers. This is like 56 newtons. This one is m times g, 10 times 9.8. Okay, g is 9.8. So I'm going to put 98 newtons. Okay, now the first part of this question is find f of k. How do we do that? You should remember there's a very important equation when it comes to friction force. The kinetic friction force is equal to coefficient of kinetic friction times the normal force, So this is that important equation. I hope you can remember this equation. Okay, so we know mu k, that's given. The only thing that we need to know to find f of k is Fn, the normal force. How do we find the normal force? Can you see the object is restricted, it's constrained to slide horizontally. So there's no motion in the upward or the downward direction. As a result, all the forces in the y direction should balance out. Okay, so I'm going to write that down. The sum of all the forces in the y direction should equal 0 because there's no motion in the y direction. And then look, there's f of n. I'm considering up as the positive direction, so I have f of n, normal force. And then look, there's a component of the applied force in the upward direction. And what's that component? That's the sine component, guys. This component is the sine component. So I have f of n plus f applied sine 30 minus fg, right? Because fg is pointing downward, that's equal to 0. Okay, and then I can solve for f of n. This is basically algebra. Fg minus f applied sine 30 degrees. F of g is 98 minus f applied is 56 sine 30 degrees. Sine 30 is 0.5. So 98 minus 28, which is 70 newtons. So the normal force on the object is 70 newtons. You might think, shouldn't the normal force equal to the weight of the object? No, it's not. It's incorrect. Why? Because there's an applied force applied in that direction. So that's going to kind of reduce the normal force from that 98 newtons. So it's 70 newtons. Now I'm going to substitute that value here. Look, 0.4 times 70 newtons. So that's going to be 28 newtons. So the kinetic friction force is 28 newtons. We are not done yet because we did this part. Now we need to find the acceleration. How do we do that? Acceleration is equal to the net force along the x direction divided by the mass of the object. How do we find the net force along the x direction? Look, that's going to be F applied force cosine 30 minus f of k. That's the applied force. That's the net force along the x direction. Can you see? There's a component in this direction parallel to the x-axis. That's f applied cosine 30, and then the friction force in the opposite direction. So that's why I have a minus sign over there. F applied cosine 30 minus f. And then this needs to be divided by m. Now let's plug in the numbers. 56 cosine 30 degrees minus 28, which we obtained over here, divided by 10. Okay, 56 cosine 30 is 48.5 minus 28 divided by 10. Okay, so then the answer is 20.5 divided by 10, 2.05 meters per second squared, to the right. And that's how you do this problem. How do you, like the last part, that's how you do it, finding the acceleration. It's 2.05 meters per second squared. That's a 5 over there, to the right. Okay, look, I solved the problem. First figured out the kinetic friction force, got the normal force, substitute the normal force to this equation, then got the friction force, and then looked at the x motion, applied Newton's second law along the x direction. So finding the acceleration in the x direction, f applied cosine theta 30 minus f of k divided by m, and that's how you get the acceleration, guys. Okay, so look, this is a pretty hard problem, but I hope you learned something important today. This is basically application of Newton's laws. Okay, I'll meet you again with another problem like this. Like my videos, follow me for more videos like this. Have a nice day, guys.